Hello guys, we are here today to talk about this book by Charles Davis, LLD. It's called Practical Mathematics, Embracing the Science and Application of Numbers by Charles Davis, LLD, Professor of Higher Mathematics in Columbia College and author of Differential Calculus, Analytical Geometry, Descriptive Geometry, Elements of Surveying, Algebras and Arithmetics. Library of the University of California, New York, published by Barnes & Byrd, 51st and 53rd John Street, 1863. Some other people have made videos talking about this book, but they made on the computer the graphics, and I have here a real model that we will be talking about what this book says. As you see here, this is the Gleason's map, and I have replaced the Roman algorithm, the 12 hours, 12 from 1 a.m. to 12 p.m., and then from 1 p.m. to 12 midnight. I replaced for numbers, not Roman numbers, but regular numbers. And let's go over this book and explain here in this model exactly what this book says. Now, the green line represents the tropics, like the Tropic of Cancer right here. We have the equator, and then we have the Tropic of Capricorn. This blue line here is the meridian of Greenwich, okay, the first meridian. So this is the 24 hours mark. So let's go to page 195, and let's read what it says. As we read, we will explain on this model exactly what it works. So look at this right here. The equatorial circumference of the Earth is divided into 360 degrees, which are called degrees of longitude. So here you have a circle, a 360 degree circle, and the lines of longitude. So you have 24 lines, because 360 degrees you divided by 24, you're going to have 24 15 degrees lines of longitude. Okay, so let's go to 221. The sun apparently goes around the Earth once in 24 hours. This time is called a day. Hence, in 24 hours, the sun apparently passes over 360 degrees of longitude, and in 1 hour, over 1 over 24 of 360 degrees equals 15 degrees. So this is the path of the sun according to Charles Davis. Starts right here, and in 24 hours, circles the Earth, passes over the Earth. So this is one day, and another day, and another day. Okay, this is how it works, exactly as it says here. Let's look at number 222. Since the sun, in passing over 15 degrees of longitude, requires 1 hour or 60 minutes of time, in 1 minute of time, it will pass over 1 over 60 of 15 degrees equals 15 degrees over 60 equals 1 degree over 4 equals 15 of longitude. And in 1 second of time, over 1 over 60 of 15 equals 15 over 60 equals 1/4 equals 15 degrees of longitude. Here 15 degrees of longitude require 1 hour of time. So it means like from, let's say, 23 to 24 takes 1 hour. Now let's start right here on the 24. So 1 hour, another hour, another hour. So every time it passes over one line of longitude equals 1 hour. Okay, it takes 1 hour. There it goes. Alright, so look at number 223 right here. When the sun is on the meridian of any place, it is 12 o'clock or noon at that time. So let's say like we are in Japan right now. This is Japan, right there. the sun goes, like it says number 20 right here. Now, as the sun apparently goes from east to west, at the instant of noon at one place, it will be past noon for all places at the east of it, and before noon for all places at the west. So the sun goes from east to west. Everything in front of the sun will be AM. Everything past the sun path will be PM. So if it's noon right here in Japan, it means that it's probably 3 p.m. in New Zealand, but it's like 11 o'clock a.m. in parts of China, and 10 o'clock here, 9 a.m., 8 a.m., and this is how it goes. So everything in front of the sun will be a.m., everything past the sun is p.m. Okay? So this is a very easy explanation on the hours of the day and how the sun goes over the flat earth, and explains also the time zones. All right, this is the time zones when it's let's point to Brazil right here. All right, when it's noon in Brazil, it's definitely midnight here in Japan. I speak to my family in Brazil sometimes. We have the same time there, but opposite, like when it's 10 a.m. here, it's 10 p.m. over there. Okay, this is how it works. All right. Now, as I said in one of my videos, I personally think that the sun does not go in a perfect circle like this, as I'm going to explain this video right now. Okay, we see here the path of 3 eclipses in different times of the year. You see the one that goes from South America to Africa. It goes from Argentina, across the Atlantic Ocean, Congo, Red Sea. Then we have another one that starts in Mid-Africa, goes through the Red Sea, India, and South China. And the last one that goes over the Pacific Ocean, over Caroline Islands. Now you throw all this info on the Gleason's map, and this is what we get. Same cities, same places: Argentina, Atlantic Ocean, Congo, Red Sea, India, South China, Hong Kong, Caroline Island. But you can see here clearly that it shows a circle on top of the Gleason's map, because this is the circuit of the sun and the moon. It's not a perfect circle like we thought it would be on top over the Capricorn, Tropic of Capricorn, or over the equator, or over the Tropic of Cancer, but it's still going in circles. And what we can see is that the sun performs its own circuit according to where whatever it's supposed to do. Now let's look at another one. This image here shows the path of 3 other eclipses. One on July 22nd, 2009, then on November 3rd, 2013, and the next one that will happen on April 8th, 2024. It goes like a zigzag, but this is not what happens. So let's throw out this info on the Gleason's map, and this is what we have. We have here exactly the same path, but you see on a circle, not a perfect circle again, as we say, but it's still the sun and the moon perform a circuit over the flat earth. And we throw everything here on the Gleason's map. That's what we have. The one that happened on March 9, 2016, and the one that will happen on April 8, 2024, and the one that's going to happen on August 27, 2027. You see the cities: Mexico, New Orleans, New York, Newfoundland, Spain, Libya, Red Sea, Diego Garcia, Sumatra, Borneo, Luwuk, Caroline Islands. Let's throw all these cities. Let's look on the Gleason's map. That's what we have. Okay, same cities, same places, and we see that the path of the sun and the moon is a circle. Okay, and they circle over the flat Earth. Not a perfect circle. One more time, saying again, they don't go exactly over the tropics, but they still go in circle. We don't know exactly the path of the sun and the moon. Exactly, like I believe, it's my belief, the sun and the moon, they circle around the flat Earth, but they do their own path according to it was designed for them to do. And this is how the circumnavigation of the Earth occurs on the flat Earth. As you see here, an airplane can go easily from west to east, or from east to the west. This is how it works on the flat Earth. Okay, just like this reporter explains in this video.
What it is an airplane that shows what future air travel may look like. Yes, it's almost as wide as a football field is long with just one seat. But just as the Wright brothers couldn't carry passengers, Solar Impulse represents the first steps in solar-powered flight. And to prove its potential, they began flying it around the world, from Abu Dhabi last year, with stops in India and China, then across the vast Pacific. Remember, it has no fuel. It then was on to the United States, hopscotched across America, powered only by the sun. And now it has crossed its last ocean, the Atlantic. Not much further to go.
From Abu Dhabi on to China, and then across the vast Pacific, on to the United States, and then across the Atlantic, and then to Europe, back to Abu Dhabi. So this is how that airplane circumnavigated the Earth. This is how all airplanes circumnavigate. There is no circumnavigation over the South Pole because the South Pole does not exist. Antarctica is this ring of ice right here. There's no circumnavigation. No plane can circumnavigate from north to south. We have the flat Earth, the center pole, the pole star, which is on top. We have the center pole and the south. Everywhere you go here is south. And that's it. This is how circumnavigation works. This is how the sun works on the flat Earth. Hope you guys have a good day. God bless you. Today is October 5th, 2018. Okay, greetings from Japan. See you the next time. Bye bye.